This is Lesson 70, Algebra 1, and this lesson covers probability and designated order. Alright, so the probability of a particular event is the number of outcomes that satisfy the requirement divided by the total number of outcomes in a sample space. Okay? The number of outcomes that satisfy the requirement gets divided by the total number of outcomes. The probability of any event is a number between 0 and 1. If no outcome satisfies the requirement, the probability is 0. If every outcome satisfies the requirement, the probability is 1. So it's always going to be a fraction between 0 and 1. So you couldn't have like 8. That can't be an answer. Or 7.5. Okay, those can't be answers. It's going to be always a fraction. So let's think about a coin toss. If we toss a coin, the total number of outcomes possible will be 2, heads or tails. And if we say, what is the probability of getting heads? Well, there's only one side for heads, so that'd be 1. So for a coin toss to land on heads, our probability is 1/2. Half the time. All right, a fair coin is tossed 3 times and comes up heads every time. What is the probability that the next toss will come up heads? So there's an important thing for you to learn about from this one. Past events have no bearing on the present event. So how many times will we toss a coin? 1. How many times could we possibly get heads? Once. How many options are there? 2. There's heads or tails. So our answer is still 1/2. It doesn't matter that it came up heads every time before that. Past events have no bearing on an isolated event. Okay. 6 green marbles and 8 red marbles are placed in an urn. 1 marble is drawn and then dropped back into the urn. Then the second marble is drawn and dropped back into the urn. Both marbles are red. If another marble is drawn, what is the probability that it will be red? So it doesn't matter about past events. We're going to forget about all that. And we're only going to worry about the marbles in the jar and what our outcome of this draw would be. So we've got 8 red and 6 green. So the total number of marbles in the jar that we could draw from would be 6 and 8 is 14. And the total number of chances of getting a red would be 8. So our probability is 8 out of 14. We can reduce that to 4 out of 7. So we have a 4 in 7 chance of getting a red marble. Again, it doesn't matter what happened in the past events. They have no bearing on this event because it's an isolated event. All right, a single dice is rolled 3 times. The results are 1, 4, and 3 in that order. What is the probability that the next roll will produce a number greater than 2? Okay, so past events don't matter. We're only worried about this roll. So on a 6-sided dice, you have 6 options. So that's our total sample space. And we need a number greater than 2. So we could have 3, we could have 4, we could have 5, or we could have 6. That's 1, 2, 3, 4 chances out of 6. And that's going to reduce to 2 out of 3. So we have a 2 out of 3 chance of rolling a number greater than 2. It reminds me of Yahtzee. All right, 2 dice are rolled. What is the probability that the sum of the numbers rolled is 7, or a number greater than 8? So for A, we want a sum of 7. Okay, so if we're rolling 2 dice, that's 12 possible outcomes. No, that's more than that. All right, let's see. More than 12 possible outcomes. Let's look at it. So if we've got, let's see, if we've got dice number 1, and we rolled it, it could be a 1, a 2, a 3, a 4, a 5, or a 6. And then we've got dice number 2. It could be a 1, a 2, a 3, a 4, a 5, or a 6. We could roll a 1 and a 1. We could roll a 1 and a 2, a 1 and a 3, a 1 and a 4, a 1 and a 5, or a 1 and a 6. Okay, so that gives us 6 chances if one of the dice was 1, 6 chances on that. So for 2, if we could roll a 1 and a 2 and a 2, a 3 and a 2, you get the picture. So we just have to multiply these together. That's going to give us 6 times 6, right, which is 36 total possible choices, okay? That's going to be our bottom. Our total sample space is 36 choices. Now, we need, how many of those chances will be a sum over 7? Well, 1 and 1 does not add up to 7. 1 and 2 would need 3 and 4, okay? And 3 and 4. 5 and 2 can make 7. 5 and 3, sum of 7. Okay, 5 and 3 will not make 7. Let's see what else. 6 and 1 would make 7. 5 and 2 is 7. 6 and 1 is 7. And none of those others. So 1, 2, 3, 4, 5, 6 out of 36 rolls could equal 7, and that will reduce to 1, 6. So for A, a sum of 7, we would have a 1 in 6 chance. All right, for B, a number that's greater than 8. Okay, so to get a number that's greater than 8, our sample size is still our sample size is still 36. We have 36 boxes here. Now, how many of them are more than 8? Well, we'd have to have 6 plus 2 could be 8, right? And 6 plus 3 would be 8 or more. Well, would it be equal to 8? No. All right, so all the ones that are greater than 8, 6 and 6, 6 and 5, 6 and 4, 6 and 3. So 6 and 6, nope, that's 6 and 1. Whoopsie, that would only be 7. 6 and 5, 5 and 5 would be 10, 5 and 4 would be 9, 4 and 4 would be 8, 4 and 5 would be 9, and 6 would be 9, 6 and 4 would be 10, 6 would be 8. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 chances that are greater than 8. So 10 out of 36, and that's going to reduce to 5 out of 18. Okay. So sometimes it's helpful to draw a diagram when they're asking you about something like that. All right. The probability of future outcomes of independent events happening in a designated order is the product of the probabilities of the individual outcomes. All right, so product, we have a keyword here. Product means we're going to multiply. So if we have events happening in a particular order, then we multiply. Let's say that we're tossing a coin. What is the probability of it being heads twice? Oops, I meant to erase. Okay, so the first time we have 2 chances. 1 out of 2 is heads. Okay, so let's write that out. Let's draw that. All right, so here's our coin, and we toss it, and we got heads, and we got tails. Okay, those are our 2 chances. Now, on our tails, when we toss it again, we could get heads or tails. On our heads, when we toss it again, we could get heads or tails. Now, what is the probability of getting heads and then heads again? Okay, so how many choices do we have here at the end? 4 total choices. And only one of them is heads, that's 1/4. Another way to do it would be this is 1 out of 2, and this is 1 out of 2, and we multiply those together. So 1/2 times 1/2 equals 1/4. So you multiply each of your probabilities if they're in a designated order. So we want heads and then heads again. All right, let's look at a problem. A fair coin is tossed 4 times. What is the probability that the first 2 times will be heads and the last 2 times will be tails? Okay, so we've got 1, first, second, third, and our 4th. Okay, on our first coin toss, the first 2 ones are heads, so that would be there's 1 chance to get heads out of 2 total chances. This one is also 1/2. Our third, last 2 times, it would be tails. So that's going to be 1/2 and 1/2. So we have got 1 tails out of 2 sides. We're just going to multiply all these together. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. Now if we drew the little diagram, we could do heads, tails, and then we could do heads, tails, and then this one would be heads or tails. That's our second coin toss. Now our third. I'm going to run out of room. Okay, now our last one. Yeah, I don't have enough room to do this. Anyways, we would end up with 16 here. And only one of them would have been heads, heads, and then tails, tails. All right, so you just multiply them when they're in a designated order. All right, the spinner shown is spun twice. What is the probability that the spinner stops on a 4 and then on a 3? Okay, so our first spin, what is the probability it'll stop at a 4? Well, there are 1, 2, 3, 4 total possible outcomes, but there's only 1 4. So oh, that's confusing. 1 chance of landing on 4. Okay, our second spin, we want to land on a 3. We still have 4 total possible outcomes. There's only 1 3 on the board, so that's 1 out of 4. So we multiply these, and that'll be 1 out of 16. Pretty easy. All right, pause the video and work the practice problems. There's quite a few of them, and then I'll work them for you. All right, first one. A fair coin is tossed 3 times. What is the probability it will come up heads all 3 times? So first toss, 1 out of 2. Second toss, 1 out of 2. Third toss, 1 out of 2. Multiply them. 2 times 2 is 4. 4 times 2 is 8. 1/8. That's the answer to that first one. A single dice is rolled 3 times. Okay, so a dice has 6 sides. So that means 6 is going to be our bottom. What is the probability that the next roll will produce a number greater than 1? So it doesn't talk about things being in an order. We just need to know about this one roll and how many of the dice are greater, how many of the numbers on a dice are greater than 3. Just the 4 and the 5. So that'd be 2 out of 6. No, they're counting the 3 as well. So that would be 3 out of 6. 3, 4, and no. Okay, never mind. It would be 3 out of 6 because it would be, let's see, 4, 5, and 6 are all greater than 3. Yes, all right. And that reduces to 1/2. So this one's 1/2. All right, 2 dice are rolled. What is the probability that the sum of the numbers rolled is a 6? Okay, so remember, when we rolled 2 dice, we ended up with 36 possible outcomes. So our bottom is 36. Numbers greater than 6. We could draw our little chart again. I guess that's probably the easiest way to do this. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 36. That's sloppy, but it'll have to work for now. Okay, so how many of these rolls could be a sum? Let's see, the sum of the numbers rolled is a 6. Okay, so we could do 5 and 1. We could do 4 and 2. We could do 3 and 3. And that is it. So 1, 2, 3, 4, 5 out of 36. And that's answered that one. There are 5 chances out of 36. So draw the diagram if you need to. An urn contains 6 pink marbles and 7 blue marbles. A marble is drawn and dropped back into the urn. Then a second marble is drawn and dropped back into the urn. Both marbles were pink. If another marble is drawn, what is the probability it will be pink? These past events have no bearing. It's not asking you to predict those ones that already happened, just this independent event. Okay, so they're not connected events. So all we're worried about is this one event. How many will be pink? All right, so we've got our jar, and we've got 6 pink and 7 blue. So in the jar, we've got 6 and 6, 12, 13 marbles total. So 13 chances. And our pinks, there are 6 chances to get a pink out of 13 total. So the answer is 6 out of 13. All right, I think this is the last one. The spinner shown is spun 3 times. What is the probability that the spinner stops on a 2, then a 4, and then a 3? Okay, so we have 4 possible outcomes. Here's our first spin. To get a 2, that's one of the 4 possible outcomes. So that would be a 1 on the top right there. Then for our second spin, we still have 4 possible outcomes, and there's only 1, 3. And then our third spin, we have 4 possible outcomes, and there's only one, well, this one would be the 4, 1, 3. Okay, so it's 1 4 times 1 4 times 1 4. 4 times 4 is 16. 16 times 4 is 64. So the answer is 1 out of 64. All right, that is it for probability. And that is all for lesson 70. Thank you. Bye.